So, any questions from remote sites?
UCLA has a question.
Go ahead, UCLA.
Okay.
I was wondering how you do your performance measurements. What tools do you use?
So those performance measurements were done with IOR. So they were done with IOR. In order to get the data, it was on a busy file system, so it's not dedicated. And as such, the data has variance in it. So the way those numbers were obtained was with 3 different trials, and the maximum performing sort of trial was taken and put in those plots. So does that answer your question?
Yeah. Lonnie, this is Prakashan. I have one more question. First of all, it's nice to see you. And when you give the MPIO hints, is that specific for Lustre, or are there similar hints for other parallel file systems? And also, okay, go ahead.
Oh, so I'll answer that first part. So those MPIO hints are implementation specific. Some of those are Lustre specific, such as the Lustre striping and the Lustre size. But on other file systems, there are similar things. For instance, with GPFS, you can't control that at a user level, but you can control the size of the collective buffering, the size of the buffer, and things of that nature. So there are similar things, although not all implementations will have the Lustre-specific stuff in it.
Okay, my next question is, can you comment on the stability of a Lustre file system?
No. I probably can't give too much of an authoritative answer on that. I guess the one thing I can say is the Lustre file system, I mean, there are issues with it, of course, but without being too authoritative, a lot of times problems in the system itself will sort of manifest themselves in the Lustre file system, but not to be directly caused by the Lustre file system. So sometimes it is a little sensitive to things. But there are lots of moving parts in the Lustre file system too. So lots of disks and controllers and things. And the Lustre file system is really built for performance. So reliability is probably not the highest on its list of goals. So as far as on the craze is concerned, performance is utmost, and reliability sort of takes a second place seat to that. So you sort of see that sort of in the operation of it.
We have a question from Penn State.
Just a simple question from slide 12. You don't necessarily have to go back. You had things that were, you have 5 sets of data to spread over 4 things. What's the best way to actually do that? Because is it better to have one OST hit twice and the rest hit once, or is it better to have them each hit twice?
Yeah, so the best performing situation is where you have each process accessing its own OST, so you don't have multiple processes accessing the same OST, or you don't have a single process accessing more than one OST. In terms of an imbalance, you can get an imbalance in your performance where you have one OST being more highly loaded than another OST. So in those cases, it would be better if you started, say, doubling up on your OSTs. It'd probably be better just to double up on all of them.
Hi, Lonnie.
Next we have
Nick at Minnesota.
just hang on a second. We'll we have a couple that have lined up. So we have a question from Renzi.
Outside your experience, because it's more of a software question, it seemed like most of what you were talking about is tuning to a single target. Some of us are writing code that's meant to run on multiple installations, and I'm wondering, can you say anything about writing software such that you can encapsulate and manage the kinds of I/O tuning that you've been talking about, so that you can write code that is generally applicable and in one set, and then maybe create plugins or some other sort of mechanism that targets individual installations?
Yeah, so in general I can say that if you're doing a general I/O scheme, it's probably best to make it very, very flexible, so you have a lot of different options available to you as far as subgrouping is concerned, the number of writers you have, and the way they actually write files. So you can do that manually, or you can actually use other I/O libraries, which actually will give you some more knobs to turn. But in general, I find that making your I/O scheme more flexible to changing situations, so the changing strengths and weaknesses of file systems or supercomputers that you may be on, you can start just tuning things. So I hope that answered the question.
Next, we have a question from NCAR.
Yes, it seems like your recommendation for big files on big number of processors is to hybridize everything, do a mix of multiple files and multiple processors, and collect different operations to different processors as well. What are your guidelines for how to go about splitting up a very large set of data into meaningful chunks in each of these categories? So we have different, we can collect to individual processors, we can collect to different OSTs, we can write multiple shared files. What's a good mix of that?
So one good place to start, it's really application specific, because you have to take into account how well your data is able to be split up between different files, and how well those different files can either be shared by a number of processes or used individually. So I guess a good way to start thinking about it is to think about logical division. So you can actually think about subgrouping your processes into groups that have portions of the data, and they can either write their file per process sort of separately from everyone else, or they can actually use a shared file, in which, in order to plan that out, you'd have to plan that the data in that shared file needs to be related enough so they can be in the same file. So it's really application specific to how you do it, but the way I generally think about doing it is creating groups of processes and then defining whether those groups of processes will write a file per process, or they'll write a shared file, and sort of divvy it out that way. So you can think of it about a multi-tiered sort of approach, where you have individual processes, groups of processes, which may have groups of files or things that are associated with them.
Next, we had a question at UCLA.
Hello, I had a question. I was wondering if you have any recommendations for handling HDF EOS, the Earth orbiting system files. They're built on top of HDF5, and I'm not sure if there's a parallel library available, or would you just recommend creating derived types?
Yeah, so I don't know how much I can actually comment on the use of HDF5. So HDF5 is built on top of MPIO. So you can pass hints to it usually, but the library itself sort of passes hints to the MPIO layer also. So in the past, I think I've looked at a couple of applications that were using HDF5. So it's harder to stripe align that. And within the library itself, it does use derived data types in order, because you have to give information to HDF5. It knows sort of what your data arrays look like and what the dimensionality of them are. So I don't know if it buys you anything to actually just go down to the MPIO layer to start doing derived data types and things of that nature. So I don't know if I can answer that any better than what I just did, I guess.
Next up, NCSA has a question.
Hi, I have a question about NetCDF. Like you mentioned briefly in your presentation about NetCDF, I was just wondering when you might want to use NetCDF, instead of using the traditional MPI input-output.
Question for Nancy?
Yeah, I'm not hearing NCSA. So go ahead, Renzi, and we'll come back to NCSA.
It seems like with the advent of solid-state drives, a lot of this will be irrelevant. How long do you see anywhere in the future of all this, of petascale computing, solid-state drives taking over anytime soon?
Yeah, I don't have any basis. I'm more of an application person, so I don't know if I can even start to answer that at all.
Thanks.
Back to NCSA.
Yeah, we were muted. Now we're ready.
Okay. So this is the question about using NetCDFs. You mentioned a little bit about NetCDF. I was just wondering when you might want to use NetCDF, in a parallel application, like, why you might want to use NetCDF instead of MPI input-output.
Okay. So I can't speak specifically about NetCDF when you'd want to use that in particular. But what I can say is that the choice to use any abstracted language or extracted library is really how well it maps to your particular application and your data needs. So NetCDF has different strengths than, say, HDF5 does. It also has different weaknesses. So if you take those into account and you take into account your specific application, how you want to use data and how you have to use data, what types of data structures do you use, things of that nature, and how well that maps to what the library is capable of doing, that's sort of a way to gauge what library might be the best to use. But it's very, very application specific.
University of Minnesota is back. Was there a question at Minnesota? I thought I heard one earlier.
Yes, we have a question.
Go ahead.
Asynchronous calls. Thank you.
Say again, please.
Does MPI-IO support asynchronous calls? So you can submit a call and have data being written to disk while compute can be going on, and then have some kind of a wait so that when the I/O is done.
Yeah, I don't. Yeah, in the standard I've looked at here, the libraries we have here don't support that at all. I don't believe.
They're discussing that in the last SD.
Yeah, so I've just sort of told here an audience that sort of thing is being discussed for the MPI 3 standard.
One last call for questions.
I got a question from LSU. Hello.
Okay, go ahead, LSU.
Can you say something about OpenMP-IO?
I don't know if I understand the question.
Do you have anything parallel I/O for OpenMP?
Oh, for OpenMP, I'm not aware of any. So I have seen applications that do I/O, but usually it's not done within a sort of a OpenMP type thread or anything like that.
Okay, thanks.
Well, Lonnie, thanks very much, and let's thank our speaker this morning. I'd like to mention that with Lonnie's input and some other help, there's going to be a CI tutor module that will appear at that site in the near future regarding parallel I/O and optimization. So be looking for that fairly soon. Now I think we're throwing the ball over to Minnesota. Is that correct, Scott?
That's correct.
Okay. We'll take
I think we'll need a minute to transition, but